Now guys, this short video I'm going to be talking about the key things when it comes to configuring LACP. So this is the first task of one of the Boson NetSim series of labs. So NetSim, if you don't know already, is a great platform for learning and applying the skills that are used for the CCNA exam, the lab skills. So the first, firstly, Uh, let's quickly just read the objective. So you will plan, implement, and verify layer 2 Etherchannel configurations in the slab by configuring Etherchannel between two switches using the link aggregation control protocol LACP negotiation protocol. So here we've got topology. We've got a client here, ASW1, DSW1. Okay, the two switches, and then you've got CSW1 as well. See, they are connected together. Here you got 10 interfaces here configured. Here you got 10 interfaces here, and that's what I can see. So there's going to be, so that looks to me indicating there's an Etherchannel there configured. So let's go into the actual lab question. So firstly, you've got a summary of some key key commands for configuring Etherchannels. Now, lab tasks. Okay, so we've got task 1, plan Etherchannels configuration. So this task involves planning layer 2 Etherchannel configurations using negotiation protocols. In this lab, you will be assigning physical interfaces to a channel group and using LACP to form an Etherchannel between ASW1 and DSW1. So that's what we're doing here. With ASW1 and DSW1, we are going to configure an Etherchannel between them. So, okay, so we're going to assign physical interfaces to a channel group. A channel group is like a family of physical interfaces, which once they're in channel group, now you're going to have a virtual interface. Okay, so firstly, the first question is how many links are required to form an Etherchannel? So links that are required to form, how many links are required? What we've got to remember is Etherchannel, when we look in the books, it tells us there's it can be between 2 and 8 links that could be form an Etherchannel, okay, between 2 and 8. So 2 is the minimum and 8 is the maximum limit, okay. So that is the first question. So we just verify the answer. We can see task 1, apply Etherchannel configurations. 1, Etherchannel requires a minimum of 2 links between devices. Okay, great. So now, second question. Which protocol is defined in the Institute of Electrical and Electronics Engineers IEEE 822.3 AED standard, and between what devices can it be used? So which protocol is defined in the IEEE 822.3 standard? Between what devices can it be used? So 822.3 AD standard is, we've got to remember that it was used to create LACP. That was the standard which defines LACP. LACP, which is okay. This LACP, one of the key things about LACP and which differentiates between PIGP is that it's open standard, can be used across the vendors, whereas PIGP can only be used is a Cisco proprietary. Okay, is a Cisco proprietary protocol. Between what devices can the LACP protocol be used? It can be used, it can be configured on between two devices, okay, that are connected to form an Etherchannel. They can be connected between those two devices, okay, on each side. So you have to configure the same LACP protocol on both sides. You can't mix and match here. You can't have LACP on one side and PIGP on the other side. That's not going to work. So, okay, so that's the key thing you need to remember. Just a side note, mix and matching is not allowed, okay, between LACP and PGP. Yeah, you can't mix and match them. However, if you got a switch, you can have LACP and PAGP. You can have LACP and PAGP configured on different Etherchannels, okay, as long as they are in exclusively as long as each channel you exclusively using PGP and LACP, you can have both types of both PGP and LACP Ether channels on the same switch. That is possible. However, you can't mix and match on on a specific Ether channel. You can't use both. Okay, so it's key to remember there. So that's for question 2. So if you check question 2, you can see link aggregation control protocol LACP is defined in the IEEE 822.3 AD standard. Because LACP is a standard-based protocol, it can be used between Cisco and non-Cisco switches. So that's something also key to remember. It can be used between Cisco and non-Cisco switches, okay, because it's open vendor. However, conversely, port aggregation protocol PGP is a Cisco proprietary protocol and only be used to create Ether channels between Cisco switches, okay, so there's no exception. It can only be used for Cisco switches, okay. Either one of these protocols will allow a switch to learn its path and capabilities and dynamically group identically configured interface into a logical link. So with each you can achieve the same thing. You can create that logical interface, okay? So that's the key takeaway from question 2 is no mixing or matching, okay? No mixing or matching. Well, you can have, you got to remember, Cisco's PGP is PGP exclusive. I mean, Cisco's PGP, with that one, you can only configure those on Cisco switches, whereas PGP you can use on Cisco and non-Cisco switches. Okay, and let's move on to question 3. Which modes does LACP support? List any factors that would determine which mode you would use. Modes LACP supports. LACP is active and passive mode. Okay, active mode is the proactive mode, is the negotiation mode. Okay, whereas passive is it's a negotiation mode. It's still a negotiation mode, but it's not. It doesn't do anything. It's like a wait. It's just a waiting mode. It's so you have to have either active or passive configured on either side, or active and active for an Ether channel to form. Because if you have passive, that's like too shy. Those like too shy switches that don't want to. They want that want to communicate. They want to form a channel, but they can't because there's no one being the more proactive there, the one that's making a move. No one's making a move, so Ether channel does not form there. So it's similar to if you have a man and a woman, and they're both interested in each other, or both are shy, then there's not going to be a relationship. There's not going to be a conversation. There's not going to be a relationship. So this is similar in this instance with LACP passive. If you've got two passive switches, there's not going to be an Ether channel there. One side needs to make the move, so one side has to be passive, or you can have both passive, and that will work as well. So those are modes that are supported with LACP. So LACP can be in either active or passive mode. Active mode places an interface into a state where it will initiate negotiation with part of our sending our LACP packets. Now, passive mode places an interface into a state where it will respond to LACP packets but not initiate any negotiation. Placing an interface in passive mode will minimize LACP traffic. After both ends of the link are configured in passive mode, no negotiation takes place, and the interface will not be bundled. The table below describes the different modes of LACP and PGP. So you can see here, PGP has auto and desirable mode. So auto is the direct equivalent to the passive mode in LACP, whereas desirable is the direct equivalent to the active negotiating state. Okay, and you got this on mode. Okay, you got an on mode, which only enables Ether channel. So, question 4 now. If we go to question 4. How many interfaces can be bundled in an Ether channel using LACP? Excuse me. How many interfaces can be bundled in an Ether channel using LACP? What happens to additional interfaces once this limit is met? So how many interfaces can be bundled? You can have you can have up to 8 active interfaces bundled in an Etherchannel. Okay, once the limit's met, you can have up to 16. Sorry, you can have 8. You can have up to 8 more interfaces just in hot standby mode. So in total, you can have 16 ports. Okay, 16 ports that are associated with that Etherchannel, but only 8 can be active at a time, and the other 8 will stay in a hot standby mode. Okay, so for both PGP and LACP support up to 8 active links between devices in a negotiated channel. LACP allows a maximum of 16 ports to be configured in a channel, but only 8 can be active at any given time. Non-active links in the LACP bundle are placed in hot standby mode, and if any link becomes inactive, one of the hot standby links will change to active mode and take its place in the channel. Okay, so it will be leveraged on if an interface goes down. So LACP uses the port priority and port ID values to determine which hot standby port will be active. Will become active. Excuse me. The LSP port priority is set to 32768 by default for all interfaces. However, you can change this value to specify which hot standby links become active first. LSCP priority value will place an interface ahead of others when active ports are being selected. If hot standby ports are configured with the same LSCP priority, ports with low port numbers will be selected first. Okay, that's the key to remember for question 4, guys. Now, you've got question 5. Can more than one Etherchannel protocol be used in the same Etherchannel? Like I said earlier, no, you can't. You can't have that. Okay. So let's review the answer again. So all ports in the Etherchannel must be configured to use the same protocol, either PGP or LACP. Not those. Additionally, all ports must be configured with the same speed and duplex. And this is something, sorry, I didn't remember to mention, guys. But speed and duplex settings are they need to be configured the same. Okay. So ports in the LACP channel that are configured with half duplex mode are placed in a suspended state and not used in the channel. Okay. You need to have full duplex mode. Okay. So okay, half duplex mode we tend to use for hubs, because hubs are quite a bit crazy in the sense that they will, when they receive a signal, they'll send out all ports except the incoming port, and this makes them a bit crazy. And the devices are connected around them. If you have a PC or a switch, those need to be those will have to make you have to have the necessary duplex configuration in order to manage with that hub. So because a switch doesn't want to have collisions with the hub. Oh, sorry, a switch doesn't want to send frames out on its interface. Okay, it doesn't want to send signals only for them to be crashed. Okay, but the hubs are crazy. They just keep sending out. They have a new concept of duplex, half duplex, full duplex technology. Okay, they just keep sending out signals. So switch has to use his intelligence, has to use his half duplex things to he has to check the actual the circuit first, if there's any signal, and if it's free, like the road is clear, so to speak, then it can send. Okay, he has to manage that crazy switch. He doesn't want to send something when that crazy switch is sending something over that circuit. So yeah. For Etherchannel though, LACP, you can't use half duplex. Okay, you need to have full duplex configured. Okay, and the speed needs to be the same as well. So meaning fast. Okay, each side, yeah, each port that you're configuring is either is going to be fast Ethernet or gigabit Ethernet. You can't mix fast and gigabit Ethernet. It's not going to work. Okay, and lastly, question 6 now of task 1. What happens to physical interfaces when you make a change to a port channel interface? So physical interfaces, guys, you got to remember a physical interface it's like okay, when you make a port channel interface, those physical interfaces, you're bundling them together. You're making like a family here. That family it becomes okay because there's these interfaces separate interfaces, but when you bundle together, become a virtual interface. Okay, a virtual interface, and it's a bit like a family. Because if you just because when you make a change, it affects all of them. It affects when you make a change on that interface, that it will affect all those other interfaces. However, if you were to make a change to the actual physical interface now, rather than the actual um, rather than the actual port channel interface, rather than a particular, like for example, you had 8 port channel interfaces. So you've got 8 interfaces, yeah, that you've configured bundled to make a port channel interface, okay, a virtual interface, okay. You make a change on one. If you made a change on one of those, if you make, okay, affects all. But if you were to just configure the physical interface, now the actual physical interface, um, that won't affect all of the other interfaces in that port channel, and you also risk breaking up the family, so to speak, because that physical channel could get unbundled. Okay, and in most cases, and generally that's not what you want to do. So let's check the answer. When you okay, so question 6 answer: when you make a change to port channel interface, yeah, the change is implemented on all physical interfaces. So sorry if I didn't make that clear. If you're making a change on the port channel interface, it's going to affect all the physical interfaces. But if you make a configuration change on a physical interface that's part of the channel group, okay. So rather than the port channel port channel interface, you're making it, yeah. You're not making the change in there. You're making it on the physical interface. Well, now change is not going to be implemented on the physical interfaces in the channel or the group port channels interface. Okay, so all the physical interfaces in the channel group, yeah, all the physical interfaces or the actual logical interface, the virtual interface itself, that group port channel interface, it's not going to affect that. And making a change to a physical interface, yeah, you might you have the risk that you might unbundle it from the port channel and place it in a standalone state. So that's task 1, guys. So I hope you found it beneficial. Thank you for listening to this video. Um, in future videos, I'm going to be going over task 2, task 3, and task 4. So please look out for those videos. Thank you.